Hi, I'm Dave Hodson from CIMIT, and I'm going to try and give a brief overview of the current Rust situation and also how things stand with surveillance systems. So let's start with yellow rust. So what we're seeing is a continuation of the threats from yellow rust on the global scale. And really want to thank Mogans and all his colleagues at the Global Rust Reference Center, who are really providing lots of the information that we have to make these assessments. I think the big news is that we've seen a new race of yellow rust detected in Afghanistan, Pakistan in 2018, and subsequently 2020. This has moved into Ethiopia. This new race, which is being termed PstS16, is really a race of concern. We see this as a race that has serious epidemic potential. Last year in Afghanistan, all the samples collected were of this race. So it's completely taken over the population in Afghanistan. And what we're seeing is rapid expansion in Ethiopia. This race also has a very broad virulence profile. So it's definitely a race of concern. We've also seen other major things happening. So we've seen the confirmation of PstS16 in Australia. So this one as a race that was previously known in Europe, but it's now made its way to Australia. We've also seen PstS14 come into Iraq. So this is indicating an eastward expansion of this race. And we're also now getting reports from colleagues in Paraguay. They're seeing yellow rust there for the first time. And that's probably linked to the recent incursions of yellow rust and subsequent epidemics that we've seen in South America. Likewise, for stem rust, we're seeing some significant developments on the global scale. In East Africa, we're seeing new variants of UG99 emerge. So in Kenya, we've seen a variant of race TTKTT, which also has virulence on this SR8155B1 gene. That was detected in 2019, and it's certainly increasing in Kenya. We've also seen another variant of UG99, TTH-TT, emerge in Kenya. So we're seeing continued evolution of the UG99 race group. Similarly, in Ethiopia, we're seeing race TTK-TT increasing in frequency. And in Iraq, 2019, we've seen the same race, TTK-TT, first detection there. So that's spread out of East Africa into the Middle East. In Europe, we're also continuing seeing this trend of re-emergence of stem rust as a disease of concern. So we're seeing, first reports from Ireland, Belgium, other European countries. First time in decades they're seeing stem rust. Then sort of ongoing work in Spain. They're picking up, some really unique races, and these, the indications are it's sexual population that's coming off the Barbary species in Spain. And just, this picture from the Global Rust Reference Center, the Wheat Rust Toolbox, this was the situation in Europe in 2020 in terms of confirmed stem rust races. So you see stem rust being recorded across Europe and also a diversity of races now being detected. All of them are currently non-UG99 races, but clearly stem rust is re-emerging in Europe. So thinking about early warning systems. So I think many of you have seen this slide before. This is just an overview of the early warning system that has been developed in Ethiopia. So this is development by Cambridge University, UK Met Office, EIAR, and also ATA in Ethiopia. So I think Chris Gilligan will talk more around the forecasting components in this session. But I just wanted to give some updates on how things are evolving with the early warning systems. So now the systems have been established for several years, and we're beginning to see some of the outcomes that are coming from these systems. So this current year, we put out pre-season alerts because of the threat of the new yellow rust race, PstS16, but also the rise in detection of race TTK-TT stem rust. We've got weekly advisories going out to partners on a quite a large scale. We've from the surveys picked up very high prevalence of yellow rust in risk areas. But what we are getting from partners on the ground is that there are indications that there's very good coordinated control that's happening in the key areas. We also undertook an impact assessment of the early warning system. So this was household surveys, over 1,000 farmers in 2 of the key wheat regions, and really positive indications coming from this study that there's real benefit coming from the early warning systems. The farmers themselves are seeing the information as very beneficial. There's very strong interest to receive the early warning information. They're reporting they've got increased awareness around rust and also a better ability to control rust. We're seeing strong signals of changes in farmer behavior. So farmers that are receiving information, they're more likely to use fungicides, and they're also spending more on fungicides as well. At the institutional level, we're also seeing impacts there. So the senior managers in government institutions, they're reporting, improved planning, operation around wheat rust management. And we're also seeing some high-level policy changes around fungicide. So having contingency plans in place that there's a reserve to cover at least 10% of the area at the beginning of the season. And also, within the National Bank, creating a dedicated desk that can handle fungicide imports and foreign currency. So they're quite big changes that are happening. And then also we did a recent, very large scale DNA fingerprinting study and clearly demonstrate the wide scale adoption and rapid adoption of wheat rust resistant varieties. And also being able to demonstrate, corresponding substantial productivity gains and economic benefits around the adoption of those varieties. So I think some very positive outcomes now coming from the early warning system in Ethiopia. Another new component of the system is this vulnerability mapping tool that together with colleagues at Cornell and Aarhus University put together a system that's really, it's combining host information with the pathogen with environment. And it's really all about identifying, areas that have got susceptible cultivars being grown. There's environmental suitability, a risk of disease, and we can come up with a risk areas where we've got a risk of infection from new races. So it's already coming into play, into use. So with the new yellow rust race, we we're able to come up with a risk assessment based on what we know about cultivars and the environment. So you can see areas of risk highlighted here. We've now got this season surveys which are ongoing at the moment, and this is yellow rust severity. And what you're seeing is where we're seeing the yellow rust coming up. It's really corresponding very closely with the predicted risk. So this is another useful tool that we can give to the decision makers in Ethiopia. We're also being able to expand the early warning systems. So together with University Cambridge, UK Met Office, national partners in Nepal and Bangladesh, we've been able to transfer the systems that were tested in Ethiopia across to South Asia. So we've had 2 seasons now. The first one was testing and validating. And then the last season, we were able to undertake large-scale dissemination of advisory information to the farmers, and able to reach large scale, over 350,000 farmers with that advisory information. We're also expanding the surveillance and forecasting to a wider regional scale. And there's work ongoing trying to bring spore dispersal forecasts into the wheat blast early warning systems. So things are moving forward in South Asia, and we're seeing some very encouraging results from that work. Thinking about wheat blast, I wanted to flag this. We're seeing a spread globally for this really important new wheat disease. We've seen spread into Bangladesh. We've now seen confirmed in Africa, in Zambia. And within both those countries, we're seeing a geographical spread of wheat blast. And I think it really underlines this strong need for increased surveillance and monitoring of wheat blast. I'd also, if you haven't seen it, colleague Pawan Singh and colleagues just put out a very nice review on wheat blast, and I would encourage you to go and read that review paper. Colleagues in Bangladesh, CIMIT and also Embrapa, they've developed a wheat blast early warning system. So this has now been rolled out in Bangladesh and also in Brazil. That system, it's a weather-based system. So it's taking 3-hourly weather forecasts. It's integrating those with a model for spore population growth, and coming up with a 5-day warning of blast outbreaks. And then information's being delivered at scale to farmers via text and email. And that's now fully operational in both Bangladesh and Brazil. So again, I think some very positive work around early warning systems that are being developed. There's also, I think, some encouraging things around some new tools. So this is work from David Hughes's group at Penn State, Plant Village. So this is using artificial intelligence, machine learning for automated detection of wheat rusts on mobile phone apps. So they've made some sort of quite major methodological breakthroughs using image segmentation and tiling techniques. And it's really kind of been a quantum leap forward in their ability to automatically detect wheat rusts. So you can see here sort of original images and then what's actually coming out from the AI phone app. So these are really giving options now to sort of expand surveillance and put it into the hands of extension agents and farmers. We can then get reliable information at scale from the field. So just to finish off, I think some take-home messages here. There's continued new threats from both yellow and stem rust. We're seeing some major things coming up or in different parts of the world. The spread of wheat blast is certainly a major concern, and this really needs some dedicated surveillance efforts. I think the emerging early warning systems are showing some good progress. And also it's encouraging that new tools like the artificial intelligence phone tools are now becoming available. I think overall, I mean, it's pretty clear there's a very strong need for strengthened and continued surveillance systems. Just seeing the continual changes and new threats that are emerging over time. And then just to thank, many partners, donors have contributed to all the Rust surveillance work over the years, and they're continuing to do so. So huge thank you to everybody that's been involved with this work. So thank you very much.